This is the Excel tutorial part 5. I'm going to show you how to create a template. Now I'm going to do this for a stats problem, but you can do this for any kind of problem where you're doing the same kind of problem, but the inputs are changing. So I went and made a tab called stats. If you're doing a template, it's a good idea to have multiple tabs and name them accordingly. First thing you're going to want to do is figure out what your inputs are. I'm going to do a normal distribution problem. So my inputs are the mean, population mean, the sample average, sample size, and the standard deviation. Okay, so I'm going to pick a mean of 10, sample average of 11, sample size of 2, and a standard deviation of 2. Okay, it's a good idea to highlight your inputs in a different color so that you know when you come back to this, these are the ones you change, don't change the rest of them. First thing I'm going to calculate is the standard error. The standard error is the standard deviation divided by the square root, that's an Excel function, of n. So square root of 4 is 2. 2 divided by 2 is 1. Next thing I need is the z-score. The equation for the z-score is x bar minus the mean divided by the standard error. Now, this looks good on paper, but what happens, this is actually wrong, and the reason being, this is supposed to be on top of the fraction, but when you write out a fraction linearly, Excel doesn't really know that this is supposed to be on top, so we need to tell it this is all to be done first by putting it in parentheses. So anytime you have a stacked fraction, you got to write it out linearly, put the numerator denominator in parentheses if there are multiple terms. Okay, now I can get the area, so I'm going to call this area left, because these equations all give you the left-hand area. This could be equals norm dot s dot dist, and I'm going to give it the z-score, comma true. That's just how normal distribution works. And there's my area to the left of that value right there. So I can't draw out a normal distribution curve for you, but this would be if we had the mean in the center right here. We want to know what's the probability of having a value to the left of 11, which is over here off to the right. This 84% would be the area to the left of that 11 with the mean of 10 in the center. And we can get the area to the right very easily by doing 1 minus the area to the left. Okay, so right there we have probability calculus, the probability. Actually, let me write this out here. This would be the probability that x bar is less than 11, and this would be the probability x bar is greater than 11. Okay, so now you have a calculator to basically do these kind of problems for you. And if let's say I want to change my sample size to 6, all I got to do is type that in, hit enter, and all of my values automatically update for me. It may help you to even highlight the answers that are most relevant to the problem. Just remember, don't change these values because these have your equations. Change the green ones that you've highlighted. So that's pretty much it. You can do this with any kind of problem. I would recommend naming it and then maybe typing yourself out a description somewhere up here so that you know what kind of problem this is for and how to use it. That's all for now. Thank you for watching.